Hello, everyone. How are you today? Welcome to my first webinar of 2024. My name's Lee, and I'm the Edge specialist here in the Perth Sequent office. So there's a good chance if you've sent me a resource-related question in the past couple of years, we've already been introduced. My job here is to train and support anyone using Geo or Edge, and I'm particularly passionate about finding those solutions to complicated problems that people manage to come up with for us. So today I'm actually going to be covering some of the tricks that I've picked up in my time teaching and using Edge. All of these points have been sent in at some time by a user of the software. So I'm hoping that at least one of these is going to provide a nice valuable idea for you. So just in a brief summary of what I'll be covering today, first of all, we'll start with stats and some selection tricks that we have built into our stat functions. Then we'll be going through compositing in the drill holes, ways that we can essentially make sure that we're getting consistent values between our estimates when comparing them to our domain estimator, and how to set up our variograms from the start. So setting up those variograms can be a little bit of a struggle at the start, but I want to make sure to go through some workflows that make sure that it sets you up for success, essentially. So domains also, and the various options that we have to pick from. So we don't necessarily just have to be tied to geology. We've got quite a few options in Leapfrog. And we'll also be then going over our parameter report. Now, if you haven't used Leapfrog in a while, then the parameter report might be a relatively new function for you. So that could be an exciting section. And then we'll be going into the interrogator estimator, how we can use to validate our block model down to a block level. Then we'll be keeping everything neat and tidy in our resource reports at the end. So we'll show you how to set up a report, the little tricks that I like to use in that, and to show you how your model is performing. Now, we are going to be doing a live Q&A after this recorded video. I'll be here the whole time on the chat. So if you have any questions, do not hesitate to ask. If it's something that's relatively simple, I'll probably answer it in the chat. If not, we'll address it during the live Q&A following this. Now, there should be a little toolbar in the to go webinar section with a little chat icon. So that'll be where you can ask these questions. Now, what we'll do now is I'll just get started with the video and let's get this rolling.
Now, one of the first tools I want to go through with you is the statistics. The statistics tool is available on virtually any dataset that has numeric data within it. And if I show you the options for just a simple assay statistics, you'll see that we have the table of stats, scatter plots, QQ plots, and box plots, etc. Now, my personal favorite is the table of statistics. It's quite a simple layout. It gives you pretty much all the numeric data you're going to need. Mean, standard deviation, coefficient of variance, etc. Now, what not a lot of people realize is that you can, in fact, add multiple category levels, which creates almost a pivot style. So before I had just my GM domains, but now I'm going to add my weathering profile. So that's now showing me not just the average value within each domain, it's also showing me the average value within each sub area. Now that is a weathering profile that I've just added onto my data set, and that's automatically giving me all the data that I need. Another thing to point out is that while the box plots are particularly nice looking, one of the coolest tools actually lives in the scatter plots. So we have a selection tool up the top, and I can select all of these, unselect them, or pick my particular selection based on almost an interval selection style. This current scatter plot is looking at the zinc versus lead. Now, while there is a positive correlation between most of the results, the points that I've highlighted are slight outliers. One of the cool features about this is if you have the assay table open, these interval selections can actually then be viewed in the scene view. All I have to do is go down to my query filter and make sure that the query filter has the scatter plot. So this makes essentially a temporary query, which enables us to then be able to isolate those areas of outliers and investigate their relation to the domain, to the other drilling, and to see if there's any cause for potential removal, or if there's any areas in particular that I should potentially be subdomaining. Now, these tools are replace, add, or remove from current selection. So you have the same kind of abilities to add new samples. I can then choose to remove all of these samples down here, or I could even choose to invert them. This selection filter isn't just related to the actual scatter plots as well. One of the ones that's probably least known is that if I close this tab and I go to the silver, here's my silver selection. I also have a univariate graph. So if you actually run the statistics on each column, the default is this univariate graph. Now currently I'm looking at just silver by itself with absolutely no domain filtering whatsoever. You can see that there appears to be multiple populations here. I've got a nice little curve right here, and this is probably more of the waste samples. So if I highlight these rows here and then go back to the scene view, you'll find that there is a univariate query filter similar to the one we just looked at, and that has already isolated the high grade areas, which, if you have a look at our geology model, follows it quite closely. So even from a quick selection, we can then find these domains without even really needing to start with our domain modeling. That is just purely based on the raw data. Now, compositing is obviously a very important aspect of estimation to prepare the data to be able to use by a domain estimation. Now, the default method for compositing is actually through the domain estimator. However, there is an alternative way to composite, and that's within the drill hole table itself. The reason I like to use that is it allows me to introduce calculations. It allows me to fully control the compositing length of all the domains simultaneously, allowing you to run tests on different composite lengths. Now, it does have disadvantages. It adds one extra step to the process, and unfortunately the compositing comparison cannot be isolated by a domain. But I'm going to show you this method and see what you think. As you can see here, the standard domain estimator has your compositing within boundary, and we can set our lengths. Now, I'm going to run some quick stats on that to show you the result. We can look at a composite comparison graph, and that tells me that pre-compositing we had 7,273, and now we have 3,144. I want you to try and remember that number. If I go back to the scene view and go up to my drill hole, you'll see that there is a compositing table. We can add a new numeric composite using the subset of codes, which allows us to create intervals for each lithology code that we have on the assay table. The result looks a bit like this. the base column I've picked on here is actually an evaluation table. We'll go more into that. But as you can see here, the lengths are set by default, but you can also edit them. So my Mafic Volcanics was sampled on a much higher rate, so I'm going to change that one to 7 and the residual length as well. You can then also pick what assay columns you want to move over, allowing you to composite virtually all of your assays in one hit. Now, the reason that I've picked the evaluation table as opposed to any coding within the assay table is because of the way that the data is treated. Now, an evaluation table can be created just under the drill holes. And what that is a very simple table that is exactly the domains being evaluated onto the drill holes. Now, you can see from the from and tos that I've got on here, there's a pretty good indicator that the GM is not snapped to the drilling. And if I run the statistics on the evaluation table, you'll be able to see those results. While it's very close, 99.9, we're not exactly snapped. It's not 100%. Now, that is going to create differences if you composite, depending upon how you do so. Now, to do this, I've created two different tables. One of these comps tables is based directly on the assay table. It's an evaluated column. Now, the advantage of evaluated columns are quite simply a direct association of the domain code from the GM onto the assay intervals. Now, the assay intervals, however, do not get changed. In this scenario, our GM is not exactly snapped to those assay intervals. So, if I run a composite table off of that coding and look at the statistics on there, you'll see that we have 3,146 counts. Now, the domain estimator was 3,144. So the reason for that is because of the domain's slight differences in snapping. Now, my way around that is to actually create a composite table where the base column is the evaluation table. That means it's exactly compositing those intervals to the evaluated column, which keeps it as close to the domaining as possible. Now, if I run a comparative stats on that one, you'll notice that we have 3,144. So we have the exact same result on the domain estimator as we do on the evaluated table compositing. So that's my preferred method there. Now, another great thing about the composite table is that we can look at our compositing comparison within Silver, for instance, to check those results, but I can also introduce a calculated top cut. So here I've created a calculation with two different top cuts. I've set a variable for LMS1 and a variable for LMS2. These variables are interchangeable. I could come back and change them at any time, and that will run through to my calculated value. Here I've created a top cut that is particular to each separate domain, essentially saying if the domain is LMS1 and it's above the LMS1 top cut, then just give me that value. It gives you a lot more control, I believe anyway, over the compositing, top cutting, and the advantage is it allows you to actually run your variography off of top cut data. So, let's move on to variography. Variography, the subject that frequently terrifies people who've never used it, but is the absolute love of resource geologists. The variogram tool within Leapfrog is slightly different from the standard. For instance, it has a single radial plot. I want to show you how to set up that variogram from the start to have a successful workflow. In particular, I want to focus on a normal scores variogram. Very standard procedure for gold estimations, as it allows you to take a skewed distribution and transform it into a normal bell curve. I'm going to show you how to set that up and how to view that. So here I have a domain, my LMS1. Now I have also set a plane of best fit, as that is the best tool we find to setting up the variogram at the start. Now you'll notice under spatial models you have the option for a new transformed variogram. If you do click on it, it will ask you for transform values. So a very simple step is under the actual silver values. If you right click, you'll see that there's an option for transform values. Now, to show you the effect that the transformation has on the data, let's run the statistics on the standard silver, and then we'll run those same statistics on the normal scores. Looking at the univariate graph, you'll see that we have essentially transformed this skewed database into the normal curve with a minimum of negative 3.6 and a maximum of 3.6. I find that the best way to view this is if you drag in the normal scores, you can set up a normal scores continuous scale, and if I look at the legend here, you'll see that I have set a scale that runs from -4 to +4, and you can then view the normal scores in your scene view as well. Now that we have our normal scores set up, I can now do my transform variogram. So I'm going to click on new transform variogram, and you'll notice that the direction on the default is a very flat plane. If you go back to the scene view at any time during making a variogram, you'll see that physical plane. My first step is always to set my variogram from the plane angle. So what I do want to point out is any change that you make within this variogram, for instance, let's say if I make this incredibly large, that change is reflected immediately within the scene view. I often tell people in my classes to make sure that they have the two monitors with the variogram on one and the scene view on the other, so they can see exactly what impact they're having on their variogram as they're working on it. My first steps are normally to lock the seal at 1 and add another structure. Then we do need to obviously address the nugget value of this data, and downhole variogram is slightly hidden under this plus button here. Click there and create a new downhole variogram. This will allow you to set your nugget based on the downhole values, and then I can start looking at the pitch of my actual variogram. So if I set that back to a reasonable value, the first thing that you notice with a variogram is the default setting is using a mean value of each sector. Now I do actually prefer the contour style. So again, first thing I do before really actually trying to make the variogram is to click on contour and fill. That allows me to find the plunge, I think, in a slightly more easier way. Another trick with the variograms is under the axis. If you click on show pair count and even scale points to pair size, this will enable you to view the actual amount of data going into informing each point. If it comes to it, I can potentially disregard something with a lot less data in favor of something with, say, 1800. One other trick I like to use with the lag distance or number of lags is actually use my mouse wheel. Rather than having to hard type numbers in consistently to test the different options, I can simply use my mouse wheel to scroll through those lag distance to find one that's going to fit the curve a lot easier. And then one final aspect that is unique to the transform variograms is the back transform button. If I click on that, that will tell me in the pre-transformed values what to expect from the seal, structure heights, nugget, etc. So currently I have a variogram of this size. If I have a quick play with those and set that curve, you'll see that that will have a very quick effect on the actual variogram in the scene view. There was a recent addition as well in the 1 and 2 circles, so it actually enables you to see the radius, length and overall size of not just the entire structures but also just the first structure. With those factors set up, I can then get started on actually making my variogram to fit the data. So now I want to talk about different domaining. So far, all of our estimations have been utilizing the standard geological model domain. But a domained estimator only needs a closed shape. In theory, you could use something as simple as a box, or something a bit more complicated, like the combination of a numeric and lithology model. The values and the domain will come from the closed domain that you pick. I'll show you, for instance, here we have an extruded mesh. Using this polyline, it's created a simple box 200 meters high and below, and creating that domained estimation using that extruded mesh has automatically given me that domain, but also filtered all of my zinc values by that particular area. That's probably not as useful though as using the numeric models. What we have here is an indicator model that I've used based off of a 10% cutoff within zinc. To make one of these, you simply have to go to the numeric models, new indicator model, where I can pick my values, select my surface, in this case LMS1, and create an existing model boundary using the same volume. That creates a cutoff numeric model that is going to be set by the boundary of LMS1 in both the area and the values used. This one that I made earlier is a 10% cutoff of high grade and low. High grade being the inside and low being the outside. Now I can take those individual domains and apply them with their own domained estimation. As you can see here, I've done both lead and zinc. Clicking on the domained estimator, all I have to do is pick the appropriate volume, and I can create an estimation using a combined estimator I've created for zinc and lead, a combined estimation using multiple passes in the high grade and low grade domain. Once this is evaluated onto my block model, down here, that will create a indicator estimation that is using multiple domains in a final combined value. Now on to possibly my favorite feature is the parameter report. The parameter report lives under the estimation folder and is a summary of every domained estimator that you have. It's a record of all the settings that you have, and it is exportable and also editable. So let's go through the parameter report and show you some of those features. Under the estimation folder, if you right click, there is an option for parameter report. The first page of the parameter report is a summary of the domain estimators themselves, including a mention of what domain was used, what numeric values were used, and the source of those numeric values. You'll notice that one of the advantages of compositing within the domain estimator is that there is a summary of that compositing that you set. So if you're doing it in the drill hole table, make sure you keep a separate record for that. As we go through the tabs, the interpolant tab is a summary of the first two tabs of the actual estimators, including what type of estimation and if you've introduced any value clipping within the domain estimator itself. The search tab is a summary of the other two, which is the ranges and the parameters you've set, the number of samples, any outliers or octant settings that you may have introduced. And the outputs are the summary of your extra metadata that is associated with those estimators. The variogram is a complete summary of the spatial models within those folders as well. Now, I did mention before that you can edit, and quite simply all you have to do is tick this box here, and that will allow you to do a range of edits. One of the more popular ones is, say, the minimum number of samples. If I change that and then click save, that is going to update my estimator for that particular pass. Now, the filtering on here is particularly handy. That's why I do normally put all of my estimations into relevant subfolders. You can filter for your particular style of estimation, such as the lead ones, or I can filter based on the input assay data and even the domain itself. So in this scenario, I'm going to turn on my indicator filter and just look at the numeric models. Now you'll see that we have all of the indicator passes and searches, and the key to doing the editing in here is, imagine if you are setting up a brand new model with multiple commodities and multiple domains. You can potentially copy all of your estimators in one hit and then make the changes that you need to make within this table. If you've got parameters that have been assigned to each domain, it's very easy to validate those estimations and make sure that they are matching the assigned parameters. After you are done with your estimation, clicking on the export key up here will allow you to create a Excel workbook that will have a complete summary of all of your parameters, and that will serve as a record for your particular estimation. If you say gave me that workbook and your GM, I could probably replicate the estimate that you've made. The only limitation I will say with the parameter report's editing capabilities is that it does not allow you to edit the variogram directly or the search angle. However, if you do not have the edit table ticked and you click on one of these lines, it will automatically open up the relevant variogram from the relevant folder. So even if it does not have the capacity to edit, it does have the capacity to provide a shortcut for you to find the exact data that you need to make those changes to. While the parameter report is definitely up there, the winner of my favorite feature in Edge is in fact the interrogate estimator. It is a function that allows you to see the status of any particular block, what composites went into it, what the search range was, and it'll allow you to find out why on a block scale you may have an estimation slightly different from its neighbors. Let me show you how it works. When you click on any particular block, for instance, I'm going to pick this one, which is slightly higher grade than the neighbors, you go to the Interrogate Estimator link here. And this list is a summary of all the composites that were found in the search of that particular block, including details such as the drill holes used, the coordinates, the values, weighting, and whether or not they were in fact included in the estimate. Now, once you have got this page open, if you do go back to the scene view, you actually see a visual summary of that. You can see that the block has been highlighted. The composites used are visible here, also the search. Sometimes it helps to make the block model slightly see-through, and you can get a very good view of what went into that block. Now, this is showing you every composite that was found in that particular block, which is up to 147. But let's just say we want to see what actually had an influence on the grade of that block. Quite simply, you go to the filter up here and you change it from found to included. There, that's showing me the 20 samples that were included. I had set a maximum of 20, and you can see the values of the zinc being used and the weighting they were all given. So if you do have a block that looks like a slightly different grade than it should be, you can look at the weighting to see what value had the most amount of influence on the estimate. And again, if we go back to the scene view, you'll see that we have just isolated those particular composites. If you switch your selection onto any other block, that interrogator estimator will automatically update to the block that you've picked, allowing you to smoothly transition through your entire estimate. As you can see here, I've moved on to a slightly bigger pass as the search range has increased massively. And you'll notice that when you go onto the values, you can actually change the radius weights. Now, the radius values, as a default, would be fixed. However, if I do pick the weighting, you'll see that you have the smaller points here that have been given less weighting for the estimate, whereas this particular point right here has completely dominated the grade. And if I go to this one, you'll see that that is likely to be the whole 45 with a much smaller anisotropic distance as the neighbours. You can also highlight and show only the assays that you want if you do wish to concentrate on any particular value. So you do have control over the visualization of what values you are seeing. Any of these interrogator estimator tables can be exported as a CSV as well if you do have a particular block of interest that you want to show how your particular estimation is functioning. You can also indicate by the index definition any particular block that might be noted, enabling you to make sure that you are always checking the same parent block if you're doing an analysis between various styles of estimates. In the past, one of my favorite uses of this tool has actually been to determine whether or not we need to introduce any kind of thresholding if you have a single assay that's completely running rampant down in an area of lower drilling density. When you are doing a resource estimate within Edge, I encourage you to utilize this tool. It's incredibly powerful and is very easy to use. Now, to finish up this webinar, I want to go through our reporting features. We've estimated our grades, we've put them all into our domains, and now I want to be able to actually show them in a final formatted report system. Our block models all have the ability to build a dynamically updating and permanent report. Down here, you'll see that we have our Octree block model with my valuations for the geological model, my weathering, and also I've created a rough rescat based on the average distance to 3 drill holes. Still a bit spotty and we could potentially refine it, but if we go to the calculations, you'll see that I've used a estimator to create a category calculation. Once you add any category, whether that be through the geological models or through these kinds of calculations, that category can be added to your report. Currently, I have my standard grade and tons report. If I open that, you'll see that I have used my density that I was calculated from an estimation. I have my geological model with my various domains, and I've used my final values. The reason that I like to use the final values is you are therefore coding any unestimated blocks with a theoretical waste block grade. This means that if I have even one block empty in my estimation, it will still be infilled with a grade value and therefore will be valid on the report. If I want to add those extra categories that I've got, such as ResCat and weathering, it's quite easy to do so. I go to my select columns and I will tick the weathering and the ResCat. If it is a category calculation, it will appear in here. If it's a numeric calculation, it will appear in the value columns. Now I can just tinker with my report, and I'm going to remove my unknown from this value, and under ResCat I'm going to remove the automatic grouping of measured and indicated, but I will show my total value. Now I have a pivot style table which has the LMS total, but also has a subdivision for the fresh, transitional, and then further on the measured, indicated, and inferred. Once you create a report with this format, it will remain so, and you can export it at any time using the export key for a Excel workbook, or you can copy the table directly into a currently existing Excel workbook. These reports also have the ability to add a cutoff for any particular numeric value, or a filter that is dictated by your query filter. Say, I only want to see measured in this particular report, or I only want to see something that exists within the transitional area. You can also use this tool, such as volume, to show, say, I want to report within my estimation box from earlier. That way you can create grey control boxes to summarize one particular area within a larger scale resource model.